Okay, back to work.
Yeah, so I definitely want to check. Okay.
Thank you so much.
Okay, let's come back to work. So, yeah, somebody tell these people slacking outside to come back to work.
They are more interested in nature.
In nature.
not SensorThings anymore.
It's beautiful. Actually, I have to say it's beautiful outside. Okay. Very soon you are the only person who can enjoy that.
What?
You are looking at you are looking at outside. Okay, so we have 2 more talks and panel sessions. So Hilke come back and then okay. And the first talk is from Kim Suk, Dr. Kim, from AIST, and she's a team leader and the chair of AIST Data Platform Research Team. And then she's also the chair of the Geo AI Working Group, and then editor of a moving feature, co-chair of moving feature, SWIG, and then editor of the JSON of moving feature. So it has all the right keyword, JSON, AI, and moving feature. So that's welcome. Yeah, thank you.
Thank you. Good afternoon. Thank you for being here. This is the last sessions. Also, thank you for giving me a chance to introduce one of my project to recently I'm working on. And this work is more related to the geospatial stuff. We working on VR. So, oops. Before start of my introduce of my project, I will have to advertise of my institute. This is one of the duty. So it's AIST and ARC. Inside of the AIST, my institute is Artificial Intelligence Research Center. So we actually consist of the 14 research teams and covered of the various research domain related of AI and IoT or data and HPC. So currently this map is actually loaded up for plan map. All of our research working on. And I think somebody already know about the ABCI of our cyber infrastructure for the supercomputer. So this computer is especially designed for AI applications. So actually, last years, the 2018 August, we start to operate of the new computing resource. Of course, we cannot compete it of Google or Microsoft, but this infrastructure is more open for the small industry and also researcher in Japan. Not only Japan, also we also open the researcher or industry abroad. So this machine is this is one of the cyber physical cyber infrastructure. So it equipped is 4,000 GPU and also 100 the computing node. So it's quite powerful computing resource for the AI, especially to oriented of AI oriented computing resource. And then this years, actually we build a new building for the cyber physical infrastructure for IoT or AI. So inside of the building is actually this is oops, where is my mouse? All right.
We're hacked. No. All right.
Yeah. So this is actually virtual visualization of 3D model, and this is our the building usually I work. And the next building we build the new building. So inside of the building, actually they have the mock environment for the factory, and then also convenience store. Also, there is some research for bio research robotics environment. And inside of the factory, we want to encourage the industry to bring their own IoT device, to put their devices and try to collect the sensor data related to the factory. Because of the factory, usually a little bit difficult to collect of the data for to analyze or monitoring. So that's why we set up this environment, and then to try to collect some simulation data, and then try to analyze to find out new knowledges. Of course, this building is more related to collect of the human data, so motion or behaviors. So how can we want to make some environment to collaborate of the human and robot together? So this is a kind of physical infrastructure. So based on those two, infrastructure, we want to develop the new. VR is a building of the open testbed for the cyber-physical systems as one of the platforms. So if you are interested to using this resource, please feel free to ask me. Then I will try to make some connections to how can using this resource. Okay, so now it's time to introduce my project. I'm working on one of the national project to organize the NEDO. NEDO is one of the grant agency in Japan. And especially the topic is that we want to develop the data platform for the next generation geospatial services. So one of the vision of we have is for the next generation geospatial services from the location-based service. We think about some space-based services. So what is a space-based services means we want to support not only human but also things, every kind of things, including robotics, to support of their perception, automations, also the optimization of the services to using. So especially I think you can easily imagine of the smart mobility, include the self-driving, also mixed reality. So how can we deliver the mixed reality services? That means it's we have to deliver service itself, as space itself. It's not only one locations. So one of these basic concept is how can we personalize service? Even though we share this space together, but depend on my situation, depend on your analysis, we have to reorganize of the spaces. Right? So actually, space, I think everybody knows the definitions, but I picked one of the definition of the space is dimensions for the height and depth and width. It means it's 3D, right? And then for the existing and move. So location may be represented of some existing, but it's not moving. But space is more movement, movement. Things is more important thing. But when we think about the space, actually depend on the user or depend on the target, what we want to deliver. Actually, there is different restrictions, and those based on the restriction, we need a different optimization method. For example, the people can work using the stair, but wheelchair cannot use a stair. So actually, we give the stair information for the wheelchair is useless, right? Also, drone can fly the sky, but maybe Roomba, they cannot fly there. So those kind of depend what kind of the spaces we want to deliver. So we need to customize of the spaces. It's not only the physical but also cyber things. So that is one of our actual vision. Then how can we support of this kind of services? So that's we developed new data platform. And before this explain of our technologies, I want to show about some demonstrations. This is this June we have the event of the Location Business Japan in 2019, and this we try to actually make the 3D map for the robot, and then also the robot is actually autonomous, traveling, and then robot try to tracking of the people's movement. Also, the other sensor also tracking the movement people's, and then we try to analyze of the movement of the people, and then try to make the map, heat map, prediction, the prediction congestion map, and then we deliver the robot there the information, and the robot using the robot using those information to recalculate their route. So this is one of the scenario we have, and this map is actually point cloud map. Everybody knows that. So we created this map just before days of the event, and then we using the LiDAR sensor to collect the point cloud data, and then we created of the 2D map for the obstacle map for the robot. So this map is very important map for autonomous robotics. So they have a real time to calculate of the locations. So this map is very important map for them. So we created of this map is on the fly, not on the fly, it's offline. And then based on this map and oops. Then you can see that is the white, the some circle. This is actually robot. So it's autonomous with his. Oh my goodness. It's raining or snowing, right? Oh my God. Now I think it's really time to go out. Wow. Yeah, and then you can also see the small, small white. And also inside, this is our booth. In the inside of the booth, we put the 3 camera and the 2 radar sensor, and they try to tracking of the people's movement. So real time, they send those information to our data platforms, and this data platform is actually designed based on the moving picture JSONs. So everything is actually communicated of the moving pictures and JSON data format. Also, we define of the API, open API, to handle those informations. And then also we created, based on this information, we created virtual environment for the simulation, or a 3D virtual environment for the simulations. And based on the sensor data, we virtually put the people's, because sometimes it's security problems. So we cannot directly using the camera informations. So we just based on the sensor information, we try to put the virtual movement, and then try to make some simulations. So this kind of environment actually we are working on. And in here you can see the certain. I'm sorry for the Japanese, but there are actually 5 research team. Actually 6 research team is collaborated together, and then one of my responsibility to manage all the data. So how can we store those information on our cluster, and then when they need of the information, how can easily access of those information. So in our platform, we manage of the point cloud data as well as moving picture data. So this is a real-time actually video. So this is a robot. It's very cute. So it's driving, and they also camera sensor. They track detect of the people's movement. Also, they send of the information to our platform. So to communicated of the platform and our cluster, we're using the OGC moving picture JSON format to share the information. But actually, moving picture JSON is not support of the real times data handling. So there is some brokers to collect 1 minute we collected of the data, and then try to convert the moving picture JSON, and then send it to our platforms the data. And then after we accumulated of the data, then we accumulated the data, and then we send the we calculated of the conjunction map, the heat map of the each small divided small cell, and then try to predict of the 10 minutes. So in the first stage, we accumulated of the data, and then based on the data, we try to we using the deep learning method to predict of the the next 10 minutes. So every time we running the model, and then the second days based on the model, we give the based on the real-time data, we accumulated 10 minutes heat map, and then based on the heat map, we predict of the next 10 minutes. And then based on that prediction information, we deliver the robot, and the robot using those information to calculate it, make the next plan of their route. So this is actually we developed, and in already mentioned, we try to communicate it of the robot environment and our cluster. We using the moving picture JSON data for that. So how can we realize over this kind of systems? So we build the ARC AI data platforms, and we call the PNT-ML. PNT-ML is point and time for machine learning. So we want to manage of the place and time together for machine learning applications. But it's various area. I think everybody have your own AI, Geo AI interesting area. But in our cases, we actually have the two interest part. One is how can we generate it, create the on map on demand. So for example, the drone maybe 10 centimeters accuracy they need. So how can we create a 3D point cloud map for using the 10 centimeter errors, or for the future maybe 20 centimeters errors. So depend on the user's requirement, we want to create of the 3D map or 2D obstacle map for our platforms on demand. That is one of the challenges we have. And then another is I already mentioned the moving pictures part, and we want to predict of the movement. And based on those movements, how can we put the new locations, new mobilities? So we actually, I make some new custom mobility allocations because make space itself is delivered. So space is maybe based on the space movement, we can put the space there. So we want to allocate it of the movement based on the prediction information. So we have actually two parts we are working on. But when we bring the point cloud data, I think everybody already know point cloud data. But one of the big problem actually big data. So in a traditional way, we scan the data and then store the data on the file, right? And then but we don't need to we created some 3D map, and then after we don't need to using the point cloud data anymore. But now we want to create it on the map on the demand. That means we want to handle the point map more frequently. So when we using the point cloud map, exactly we face of the challenge of the big data problems. So already know about the volume, the point cloud is a huge large of data. So how can we manipulation or visualizations? Those is a big issue for to handle the big volume of the point cloud data. Also variety. So there are so many sensors to collect the point cloud data. So based on depend on the sensors, they have different scale, different density or accuracy. So how can we manage of those different type of the point cloud data? Then we most big challenge is how can align and how can registers, how can integrate it, different type of the point cloud data on the same, to using more general map. And last one is velocity. So MMS system or drones is more frequently collected of the LiDAR data. So we also want to use manage of the point cloud data. Also consider the time informations. So everything is actually big challenges, and then we cannot actually solve all of the problems. So I want to share these challenges. But anyway, we focus on the three technologies. One of the how can manage of the data, and how can align the point cloud data, and how can visualize of the point cloud data. So one of the things is this is OGC. So everybody knows the DGGS. So I actually heard the DGGS system on the OGC meeting, and then I think, oh, this is good for the managing of the point cloud data. So we applied of the DGG systems to manage of the point cloud data. But one of the problem is actually if we using very small resolution, large resolution of the scale, then the DGGS code is huge, and then it is a little bit difficult to represent it 64 bit. So we need more bits to represent it of the code. In that times, we have one of the problem is encoding, decoding, and we pay more cost for the encoding, decoding. So actually, to manage of this code, we developed a new mechanism to more efficiently encode and decode of the information. And then using the DGGS, we make the parallel. We're using the distribute the file systems, and then to manage of the point cloud data. And another thing is actually alignment and registration. What is alignment and registration is you can see the different colors. So a different color is actually represented of the different time timestamp of the capture of the area. So based on this, we have the we try to same area to sensor captured of the 5 times. But the problem is usually the sensor, they're using the local coordinate system. So inside, especially the indoor space. And then we bring all of data, they overlap in the same area. So this is not map, just to overlap all of the point cloud data. So how can we align to make the one whole big space? Then we have to mapping of the certain point, control point. Then we decided of the control point, then certain tool is automatically try to align. But the problem anyway, we need to select control point. But if we in this area is small, so we already know about this point it may be matched. But if we think about the whole urban city, then a little bit difficult to human can make those kind of work. So how can we automatically to try to align of this kind of things? And that's why we think about more. It's also big data problems. So we actually make some algorithm based on the parallel processing. So I think I already know about the Spark. So based on the Spark environment, we make some operation to handle the point cloud data. So one of the implementation is Landsec. Landsec is one of the famous algorithm to detect the plane. It's a kind of a clustering algorithm based for the point cloud data. And this is very robust algorithm, but problem is very low performance to compute. So we developed some algorithm to using the Spark and the more best calculated of the planning. And for example, this is Odaiba area, and then is using this data we try to detect of the plane informations. So it is this part is only showed up with visualization, but actually the processing is we using the parallel processing environment. And then next one is the visualizations. Compared to the images, point cloud data to recognize of the semantic more difficult because you can see that this is images, but we try collect the point cloud data. There's noise and then certain how to say, missing part. There are many parts of the missing. So we a little bit difficult to recognize. Okay, this is PC and this is the stairs and wall. This we want to recognize of those kind of thing. So now is many also vision people start looking the point cloud. The recognition based on the deep learning, and also we using one of the algorithm to try to detect of the object. And then, but why we want to detect of the certain object? Because we want to automatically create the 3D model. Currently, 3D model is so many people, lots of the manual work by human. So how can we reduce of those cost, human resource to cost of for the human resource to create it of the 3D model? So we think of the AI technologies, maybe one of the good, candidate to apply. So basically, yeah, how can we create 3D model from the low point cloud data? And currently, we start of the indoor space. Indoor space is not indoor object. So it's, for example, indoor object. This is indoor object. But we think of the space is this room. So because object is more difficult to modeling, but now we have another idea to how can create it of the model. But anyway, in these times we focus on the 3D space. So if this is point cloud data, then how can we create it of this kind of model? So there are several ways, and we created one, the open source. We said pins out, point in, and space out. So we created some systems to using the three actual open source. So one is the point net. Point net is kind of anxious of the deep learning for the point cloud data. Now is more, we have more sophisticated method, better performance. We have a better method than point net, but we just using the point net because we are our interesting is not deep learning itself. How can we using the deep learning to create it of the 3D space? That's why we just select the very simple, the algorithm and point net, and then using the point net, we classify of the meaning, the semantic meaning. So this is word, this is desk, this is the television kind of semantics, and then after segment of each point, we try to create it of the polygon. So try to create the polygons. We using the PCL library. So PCL is lots of functionalities to operate it. And using the PCL, we created a certain base. And then finally, we make the feature. So this is a wall picture, and this is a room picture. So to give those kind of feature, we using the CTDB, 3D CTDB is the CTGML. So we using the CTDB, we created each record based on the meaning, and then finally we get the CTGML model. So I will show you some simple example. This is point cloud data, and then we try to start of some deep learning to record, segmentation work, and then after segmentation work, we can get this kind of level information. So LED is, sorry. Yeah, LED is ceiling and green is floor. This is the segmentation. So segmentation, each point they have the label. So now it's now still point. So now how can we convert of the polygons informations? And for that we using the PCL library, but actually there are certain way. So I will, I cannot explain all of the detail of the process. And then finally we created polygon and put the data into the CTDB. Then, oops. I'm sorry. So then when we export of the CTGML, and then we try to visualize of that, and then we can get this kind of model information based on the point cloud data. So this whole process is automatically generated of the. And another thing is how can we predict of the movement? Also, we applied of the deep learning. So deep learning is basically they using the images. So we also created a certain image map for the movement informations, and then every cell has some density of the peoples or flow of some movement, and based on this movement we apply of the CNN and RNN. So using the CNN we auto encoded of the informations, and then based on the encoding information we applied of the RNN, actually LSTM. So we developed a new algorithm to predict of the movement. We already published the certain the papers of the KDD, and so this information whole combined of those information we created we realized of the demonstration what I already showed you. That's it. So thank you very much for your attention.
Thank you, Dr. Kim. And then, any questions? Very informative, a lot of content. Any questions? Dean.
So just on the part just before, when you're doing essentially the feature extraction from the point cloud, so is it, I'm curious about the process. So did you have to do training in order for it to recognize and in terms of the extraction of the polygons, or that was all done in that PCL library? And then like, is that whole process fully automated, or you have to like clean up 10% of it? So for example, how does that scan recognize doorways? Doorways can be tricky to find depending if the door is open or closed.
Yeah, it's so in our current work, we actually recognize of that this is open door or closed door. So based on the open door or closed door, we put the attribute of information. So door, the one of the attribute of the door, and then close open. And anyway, so in these times we didn't try to training because we using this building parcel data is of this temporal data. So in these times we more interested in how can create it of the indoor, the 3D model automatically. So maybe the building parcel data already cleaned, right? So very clean. Already they remove the noise, and already they provide of the training model. So we just using those model, and then okay, now it's classified. And this is a point of the door and point of the wall, and also they have a certain missing point. Then how can we create it? So in the first time we think about the triangulations. Every point we try to the triangulations, and the merge. Make the merge, but because of the missing point, it actually didn't work well. And now actually we're using the plane information. So we detect the plane and then try to intersection part, and those kind of process we make find a certain rule. And now it's automatically we created of those model based on our algorithm. But it's true, because if we really using the raw data, maybe then I think it's much difficult to recognize of the segment of the information, semantic segmentations, and for that we trying to using the raw data, and then how this algorithm work, and then maybe it doesn't work, we have to build up the new training data. Right. So currently we are more interested of the factory environment. So we are start of the annotated of the point cloud data based on the factory environment. And actually FCU helped us to develop the annotation tool. It's more not each it's not manual work, but also we're using the deep learning algorithm more have more efficiently annotated of the information. So we actually developed a tool for annotation tool, and based on the annotation tool, we try to running of the data model, and then also based on the model, we try to segment of the semantic, and finally but our current interest is more to how can automatically create those 3D models.
So at this point, it is predominantly automatic
Yeah.
to get the 3D model
Yeah.
that you can use for indoor
Yeah.
navigation. Perfect, thanks.
Let's give a round of applause to Dr. Kim. Thank you very much. Of course, please reach out to Kim for doing the dinner. And you have a glass of wine.
Okay, so next speaker is Marcus, and then who's this guy?
It's up. It's actually minimized.
Okay, great.
Should be.
Thank you, Marcus.
Okay. Hello, I'm here to talk about the Internet of Things security, SensorThings, and technology communities. And again, I'm Marcus Alzona with Keys. So maybe I wanted to start with just talking about communities. We're all members of multiple communities. Your personal community, professional community, and for lack of a better word, geographic community. What country you live in, what state you live in, what city you live in, what road you live on. So we're all members of multiple communities. Now, in technology, here are some communities that I'm putting up here in terms of discussion: hardware, software, whether you're doing services, integration, security, and then more perhaps on the domain side, IoT, aviation, public safety, cyber, geospatial, healthcare. So two of the communities I live in is, well, this one right here, IoT and OGC, and cybersecurity. And so what I'm trying to do here today is talk about some issues that I think are somewhat of a crossover, or perhaps that you on this side might be interested in learning about some of the things going on the other side. So as we've seen here all day today, there are a lot of new opportunities coming with IoT. Decision-making, automation, convenience, many different things. However, that's for this community. I like to say it as people who are trying to do something. You're trying to affect some positive change. For the hacker community, IoT presents a lot of new opportunities too, just not in the way you want it to. And also for the information security community that is out there to protect everyone, it's potentially a lot of problems or issues, whether it's denial of service, network, information, physical, etc. So that's one of the sort of the two community problems that I sometimes look at in IoT. Now, let's maybe discuss some security events. Ed mentioned the botnet, CCTV earlier. Other things like, I don't know if you remember recently, or a few years ago actually, one of the first connected vehicles that was in production and being sold, they found an exploit into it where you could remotely get into the system and infect the vehicle control system. And for example, you could apply the emergency brake or basically apply the brakes hard while you're driving down the highway at 60 miles an hour. Those type of things. I mean, it's a connected vehicle, but it's a connected technology, connected, I want to say, things out there. Another is the roadside signs example going on for a while, where people can go in and modify the roadside. So instead of saying, traffic ahead or construction, it says zombies ahead, run. So, which can be amusing, but as this infrastructure gets connected even more, and you're going to have an increased problem with that. And it's just showing how you can actually do intrusion on these systems, especially when they're out in the field, which when you're talking about IoT, at least the sensor part, they're all out in the field, so unprotected. So how does the security community and or the hacker community get into these systems? So if you're a white hat, basically if you're a security professional who's trying to find vulnerabilities to try to patch them and try to identify them and help you, you do penetration testing or pen testing. So you're mimicking those real world attacks to try to get around the security that was put up to prevent people from getting in. And pen testing allows you to see how well your system tolerates attacks, how sophisticated the attacker has to be to get in. Can they get in by just plugging something in and typing a default password, or do they have to go through a lot of these procedures? So some of the hacking tools, Kali Linux, there's a specific Linux distribution for penetration testing. So you can just download Kali Linux, install it, and then it has most of these tools, or a number of these tools. Aircrack, basically, it's to see how secure your Wi-Fi password is, but you can also use it to actually break, with sufficient time, or nearly any Wi-Fi network, at least the consumer ones that are out there and some of the commercial. Different tools, map out your network. So you get onto the network and then you get a connected camera. This is a router. This is a file share. And by the way, it's this version. And then you use things like Metasploit or other things. It says, oh, well, you have a device with this version. Well, these are the 5 exploits that you can use to get into that system. And then IDA Pro, which is a disassembler, which we'll get into here. So these tools, except for the last one, sort of get you in, by just scanning the network. If the device is vulnerable, that's the if, it'll get you in, and you can even find the devices on your network depending on the network configuration. Now, what if it's not readily apparent for that case? Well, then you can hack the hardware. So if you see here, there's a router. Pull it apart. There's procedures, there's training classes that deal with this. You can look at the different chips on there, figure them out. You try to look up the specs and figure out, okay, well, this is a NVRAM. This is a serial port. This is the wireless chip. This is et cetera. So you can find out, or this is the CPU as well. You can find out information about the system and say, on here, it's not like there's any hard drive on here. It's non-volatile memory, but in the end, it really is some sort of Unix variant running on there. And what you can do after you've sort of identified, hey, what is this hardware, is you can, as you see on the bottom, you can identify the pins that give you a console, and then you log in like any normal Unix system. And if it has certain default passwords, you can get in if you've identified, well, it gives you that console, and even if you can't get in by just the console access, you can also download, there are other things that you can clip on. I don't have a picture of it, but you can clip it onto the non-volatile memory and download the image. Once you have that image, there are other tools, I should have listed it, it's Binwalk and other things that sort of scan that image and say, oh, here is a root file system that's, so it's a compressed format, and it'll identify and say, oh, here's a root file system. From there, you can use tools such as IDA Pro, which is, I've referenced it as the last one there, and look at the image, look at the hex there, and see what you can find. Sometimes you can just, after you've extracted the file system, it's non-encrypted, so you can just unzip it and then even if it was an embedded device, you have your entire Unix file system with any passwords or configurations or certificates that the manufacturer has loaded on there to protect it. All of a sudden, it's open, and you have the keys. And depending on how you implement your systems, is sort of why I'm trying to do this overall talk. If you've made it such that it's the same key for every single device that you have, then now every single device that you've deployed might be compromised. So the hacker community, the cybersecurity hacker community has, well, there's many security conferences, but some of the sort of crossover ones that are computer security and sort of the hacker community, you have DEF CON, which is in Vegas, one of the longest running ones, one of the largest. Black Hat, which is similar to the RSA conference, RSAC. So that's sort of corporate security, but it's set the week before DEF CON. So it's sort of like, so you can get your company to fly you there, you know, a week ahead of time, and then you go to Black Hat, and then after Black Hat, or yeah, you stay for DEF CON. There's regional conferences they're called B-sides. They're supposed to be like the B-sides of a record for more localized talks or talks that, you know, aren't quite big enough yet to go to say DEF CON or one of the other things. So there's a B-sides DC for Washington DC, B-sides Charm for Baltimore, B-sides New York, B-sides Las Vegas. I have no idea if there's a B-sides Calgary. I wouldn't be surprised if there is one. It's very spread out across the world. ShmooCon's a big one in Washington DC every year. Not the people who, there are about like 30,000 people who go to DEF CON and Black Hat and Chaos on the other side. Chaos is in Europe, by the way. So Shmoo is more on the 2,000 to 3,000. So, and it's in DC, so it has an interesting mix of, I guess, activists who are concerned about government and people who work for government who are concerned about protecting government, but they're all sort of the same community. Hope, other things like that. So now, things that go on in the conferences, besides talks, they have things called like, well, in this case, Lockpick Village and Capture the Flag. So Lockpick Village, you're literally learning how to pick locks. So, you know, in the issue of physical security, actually I should have brought it up as a prop, but you know, you can get little screwdriver sets to open up pretty much any device, right? So even if it has the funny little screw heads, it doesn't matter. You can get into any device. And then for locks, yeah, it's really simple to learn. It's actually fun, you go. But that's one of the fun activities they have at the conference. You learn how to pick locks. And you can buy your own lock picking set right there. Another's these exercises called Capture the Flag, where you're basically, it's like pen testing, but for fun. Like you have different people, it's like a challenge. Like, okay, well, now you got to find the Wi-Fi access point somewhere in here. Okay, now you got to try to hack into it. And now that you hack into it, find the server there. Oh, and now find that information the user's login. And then so it's a contest, and you have different teams doing it. Now, this is a hacker conference, so, I mean, not this, but you know, these pictures are from a hacker conference. That community is very, very, very sensitive about picture taking, if you were to believe that. So the pictures here actually are, the B-sides DC has something called Crypt Kids, where it's like you take your kids to the conference day. And so, yes, I may or may not be related to the boy and the girl in here. But yes, and even that year, or one of the years, because yes, she actually was the fastest one to pick the level 5 lock, and there she's finding the Wi-Fi hotspot so you can identify it and try to get into it. And then, and yes, they actually literally had a Crypt Kids Internet of Things thing where they were looking at Arduino boards. So IoT Village, that's a, well, it's sort of described here, but essentially it's an ongoing exercise or collaboration where at DEF CON and a bunch of the different B-sides, it's like almost like a traveling roadshow, they bring a bunch of different devices. These are consumer IoT devices, consumer routers, consumer network NASs. But you go there and you try to hack into them, and they just have them laying out, and you can sit down and you plug in your laptop, you can get on the network, and you try to look and see what exploits what exploits you can apply to them, and it's sort of a collaboration. They also have talks at DEF CON. So here is a list of the IoT Village DEF CON 26 session. It's just the titles. So a security researcher's guide into the Fitbit ecosystem, circumventing security controls and network accessible services, regulatory trends in IoT security impact on the research community, an IoT security manufacturers panel, next gen IoT botnets, hacking a NAS, and then look, there's one even that you can hack into electric vehicle charging stations. So this is what they're looking at. This is what they're interested in doing. And this community is not, it's mostly the people who are interested in tinkering with it, and then there are the cybersecurity professionals who are sitting on the other end, usually trying to defend to it too. So, I mean, but there are other people, there are plenty of other people who are not doing this just to sort of get it out there and try to improve society. In fact, they're the ones that aren't publishing their information because they're using their information. So now that I may or may not have gotten people worried and upset, let me talk about addressing these things. So one of the things to think about is threats, vulnerabilities, and risks. So a vulnerability is, one of these bugs in the system that allow you to get in. Threats are somebody or some event that might use that ability, and then the risks are, well, what happens to that? What happens to you if A or B or C happens? Or what is the downside? What's the bad thing that occurs in the end? So in looking at that, there are different, there are many approaches. One approach for at least the U.S. federal government is they have a number of different standards and policies. FISMA, FIPS 199, FIPS 140, and all the way up to 883, which is a very involved security assessment that is not fun, but is very useful, but it's really deeply involved. And for example, the FIPS 140 for cryptographic modules, that validation is actually by the US NIST and the Canadian Communications Security Establishment. So there's different ways and different controls you can use. One that I think is useful just to sort of explain what's going on as when I'm talking about risks is the FIPS 199, the standards for security categorization. So you have, it's a sort of a two-part issue. Like when you're asking questions for a given system, or whether it can be hacked or not, or rather, what happens if it is hacked? So, or what happens if the confidentiality is compromised? In other words, information you had in your system somehow gets out. Integrity. The information that you have on your system or that you're publishing out is somehow modified. And availability. Denial of service. If all of a sudden you can't access the server, and then you look at that and then you say, well, what's the impact? High, medium, low. Some examples might be if you're running a not exactly IT, but if you're running a public web server that's publishing public data, confidentiality. That's a low risk because this is public information. You're literally sitting there and trying to send it out, so you don't mind if it gets out for the most part. I mean, whereas say your device is recording health data for a patient, then there's all these different, in the US HIPAA rules, or there's a lot of regulations for managing somebody's healthcare. So confidentiality might be high. Where you might affect things here would be, I want to say, integrity and availability. What if you in sort of an IoT device that's sitting out in the field, what if you mess with its readings? What if, I mean, we talked, or actually on the first day, we had somebody talking about GPS spoofing. What if it's a flood sensor and you're saying that there's a flood and there's not, or vice versa. So given all that and you're evaluating the risks, so what do you do? Or how do you mitigate those risks? And these aren't, just to be clarified, these aren't saying you just do this and you're fine. It's just, this is like part of the conversation. So one is that it's boats on the edge. So boats, not moats. When you think about moats, I sort of want to say you think about firewalls and you think about moats. In a typical organization, a lot of times people think, okay, well, I'm behind the firewall, so I'm okay. That's for IoT, that's just not the case. It's really not the case at all to begin with, but for IoT especially, because it's edge computing. I mean, to one degree or another. So that the badge scanner, as we walk in, that's outside a security perimeter. It's outside I'll say the normal computing one. Okay, maybe not that one because we're in a physical perimeter here, but when you're deploying something outside or you're deploying something in a remote location, all of a sudden you're not inside a firewall. And if you have a connection directly back into the firewall, I mean through your firewall into your organization, that's even worse. So you have to think about, I guess you have to consider edge and endpoint device security, the security on the device in the field, not just protecting your network, but protecting the actual device. The network security, how are you getting back? What methods, are they public, private, et cetera, encryption, and intrusion detection. You want to have at least a little bit of mechanism to figure out, well, yeah, my device is compromised. So here are some additional ways. So you want to manage your identity, the different identities in the access, your users, your devices, your things, the certificates and the encryption keys and the passwords, and update and patch management is actually really big, because for a lot of, I would say a lot of consumer IoT devices, the large companies that produce them have some sort of frequent updates, some sort of regular updates. The other ones that you might get, they'll get deployed and they'll never be updated again. It'll be out there. And so in the end, say that device is running a in its web server interface, it's running a version of Light HTTPD from 2013, which has, you go to Metasploit and it has these 15 different vulnerabilities. So you can just basically get into there and get full control of the device. So it's important that you update and patch your devices, your systems. So you want to try to secure your device as much as you can. Physical, the physical security, although you might have a lockpick, right? Platform security, in other words, if that example of that Jeep or that vehicle where somebody was able to activate the brakes remotely, part of the I'm going to say the security security profile, the part of that exploit was done because the data service, what happens is connected over a 3G connection. That network connection allowed all ports to come in, and secondly, they left a separate service running on one of the other ports that they were either using, I can't remember if they were using for testing or it was just one of the services that came on it. They weren't using that service, but they left that daemon running on the device. And so somebody could use an exploit onto that, get into the system, and then ultimately trigger the brakes. And network security. Now, some of this is that you need to have some sort of a security assessment to one degree or another. Just do an assessment, see what your risks are. And then you also have to look at your software supply chain. So if you're implementing a great service, but you're leveraging this other platform. You have to make sure that platform is updated regularly and that you know its vulnerabilities, or hopefully lack thereof, but et cetera. And then finally, you need an incident response plan. So it's going to be one of my concluding points too, but if you do have an incident, if you are hacked, if one of your devices is hacked, or one of it's compromised, what do you do? And how do you respond? You don't want to sort of be thinking it up on the fly when it happens, because at some point it'll happen. And that's like the double-edged sword. This is very, with consumer IoT, people are just looking at it all the time. As you go into commercial and then sort of institutional government, not as many people are looking at it because it's harder to get the device and harder to understand the system. However, the more successful you are with it, the bigger your profile, and then the bigger chance that some random person is going to be like, oh, I want to check this out, or start plugging with it, or organized crime, or organized crime / non-state actor, or a state actor. So the range goes there. So the more successful you are, the more risks you're starting to take on. So you should just be thinking about it, is what I'm trying to get at. Then how does this relate to SensorThings? Well, we've been off and on talking about it. I mean, I feel like SensorThings has always been very much a do. How do we do? How do we do something and make something better right now of these current processes? And that's been the focus, and it's been really successful. But going on with what I just said, the more successful it is, now it's not a system, it's a standard, but going forward, at least I'm advocating that we start thinking about how could we, or how would it be appropriate to try to build in hooks to security, not implement it itself within SensorThings. So that doesn't seem to be the proper approach. At least I don't see it. But how do you reference other things, and how do you help with device management? How do you develop with keys or cryptography or certificates? Are there different ways to do it? You can even, whether when you're communicating the readings of data, or just setting up device, or devices first authenticating, or it goes all the way up to both public cryptography, and even could you use distributed ledgers for that? Although that's somewhat controversial, or I don't know. At least that's when we talk with Andreas about it. His thoughts on that. And then also, how do you do it? Like, do you do it in SensorThings as an extension, as part of 2.0 or 3.0 or some other thing, or there are different methods of doing that? Wow, that's interesting. So that's probably, yes, a industrial control system. So my final thoughts on this: you should know your vulnerabilities and know your risks. Which, remember, vulnerabilities are not the same as risks. Everything can be hacked. You should just sort of, hopefully, by showing those chips before, given enough resources or focus, pretty much anything can be hacked. It's just the question is it worth it to them to do it? And really, that is one of the trade-offs. So you need to plan accordingly, but risk-based, because if everything can be hacked, then we should just do nothing all the time, and that's not the case. You have to, that's what we're here for, doing these great things with IoT. So we need to continue doing that. It's just, as we get more successful about it, we need to keep that in mind. Inter-community and intra-community collaboration. So you probably want to talk to some cyber people, or look at, do some evaluations of your system, or whether it's with different departments, with different agencies. There are programs that actually, I know that that the U.S. government, that the NIST has and DHS has, where they'll actually run scans on your system if you really want to. You know, and do an evaluation and try to give you a report that, hey, you might have these vulnerabilities. So there are things that you can leverage. And then finally, incorporate security into your system or standards development. So when you're designing your system or the next phase of your system, you might want to add some of these features in as part of the actual core features. And I think that applies with standards too. So, all right, that's what I have to talk about.
Thank you very much, Marcus. And I think we have room for one question, but I felt I need to hang out with you more often. You go to fun events. Okay. Any questions? Or are all scared?
We talked about a lot about the artificial intelligence here today. Is there a black hat artificial intelligence? I mean, is artificial machine learning already being used to find new vulnerabilities?
Oh, interesting. Yes, I don't have the details, but yes, I did read about both different efforts, but that research is going on, and I think there was at least one instance where they were sort of, you're trying to, I'm not sure in the strictly AI sense, or that how you would typically apply it, but as far as I'm thinking, even certain platforms are designed, certain security monitoring platforms are designed such that it starts picking up the patterns and then saying, oh, well, you were searching for this, or you were looking for these types of events. Here is an interesting correlation as well, and it brings that higher on your sort of dashboard. It isn't exactly that, but I'm thinking that, for example, some of the tools, like very popular tools like Splunk and other things, it's meant to go, meant to have you, I mean, it gives you a dashboard to sort of search for things, but they're adding things such that it would pick up at the patterns that you've been looking at and then present similar patterns to you. So, yes, and it's gonna get worse or better, or depending on how you look at it. Again, it's
Kind of scary. I mean,
yes.
because that would probably be a very efficient way to find things once it learns how to analyze how things are coded and how things are actually done the usual way.
Yeah, the tools that IDA Pro tool that I showed, that once you get the firmware off, it allows you to go in, and then even if you couldn't get into most things, maybe it will search the binary for, when you get down to machine code, you look for, I mean, there's processes, and professionals do it, but to look for, say, where you're, the code that does the password check that allows you into the system. And once you figure out how to find that, you go to that line, and it's a string compare, right? If password entered equals the root password, then let them in. And you modify that just to say return true. And so all of a sudden, and then you write those 8 bits back or 32 bits back, and then now there's no root. You just log in. So the automated scanning of binaries, that is definitely something that's going on. Or research is going on to try to find exploits and things. So
I have a question. So when are you going to organize a tutorial on hacking into Wi-Fi's and IoT devices at TC? Maybe December. Thank you. Well, thank you very much, Marcus. So we have a very packed agenda, but I think you'll agree with me that it's a wonderful day.
Yeah, but we still have the last session, panel session. I would like to invite Google's Ed Parsons and OGC staffs, Luis and Ingo, to the stage. We're very short but interactive panel session to wrap up the day.
Very short. Very
short. Very short. Yes, but you know, beer doesn't start until 6:15. So if you are leaving now, it's just nothing to do.
Where are my notes? Beer is always a dangerous thing.
Yeah. Oh, my notes are here. Okay, can the three panelists introduce yourself with, so 30 seconds for each person. Thank you.
Hi, I'm Ed. Oh, come on, you know who I am.
And tell one thing we don't know about you. Yes, I forgot that.
There is nothing that you don't know about me. I'm very open.
Ingo with OGC staff. I just decided I probably want to become a member of the hacker community. It sounds such much more fun than what we do here, actually. Plus, they do have those cool competitions, and I think we never have any competitions here, right? We should think about competitions at those meetings.
Like a pick a lock. That's a good one. That's a good one. It's a lifelong. It's a very important skill. Luis.
I'm Luis Bermudez, OGC staff.
Something we don't know about you.
I'm OGC staff. With you?
Oh, Luis is we learned last yesterday he's a celebrity in Colombia.
Celebrity because of ice skating?
Yeah, who's skating in Colombia? Okay, question. So, choose one of your favorite or the IoT application impressed you the most.
Can you repeat?
The IoT application impressed you the most. You find it most interesting. Who want to go first?
I mean, I think what's happening with the smart cars is incredible, and it's not just one IoT, but it's all the system that goes with allowing the cars to just move by themselves and everything that goes related to that. I think that impresses me a lot. We've gotten very far to make that happen. And I will say, if I will ask my girl, is when she talks to Amazon Dog and she plays her music and it's just hands-free, and she will never learn to maybe operate any recording. She just says, Alexa, play something, plays, and she starts dancing. And that voice recognition we have gotten so far, which grabs a lot of IoT devices, it's amazing. I think the interface that we're expecting with how we communicate with everything is changing, and we're just starting scratching the surface of how we're going to interact.
Thank you. I agree, actually. If you want to watch a video, I have a video of my son when he was 1 year old and said, okay, Google. It's 1 year old. No.
Well, the most impressive thing for me is home automation. Of course, you have people coming into the living room and saying, turn on the light, and the light doesn't go on. And then they take out their phone, load the app. The command was different. I show you again. It is, hey, turn on the light. And then the light goes on in the corner. No, not that light. And again, phone, another app. And I still wonder where we stand with so many IoT elements and home automation techniques and stuff, because I have the impression that is playing around at the moment still. And I'm really impressed how much press coverage this nonsense gets at the moment. And I've not seen any person who is really using all those home things in an efficient way. You do? Okay, now I learned how this can be done efficiently.
It did take a lot of effort to make it efficient. I will give you that point, absolutely. But yeah, our household uses all of those IoT devices. My daughter is very happy to stay in bed and be able to switch the lights on and off with some level of consistency. So it does work if you put the effort in. My favorite is actually quite an old application. There's one that I think was the on-ramp to a much bigger story in terms of new mobility models, and that was Zipcar. I don't know how many people have got Zipcar membership. Zipcar membership is basically one of these short-term rental things. And this was probably 10 years ago, it was originally introduced, where you could find a car somewhere in your neighborhood using an app on your phone, then go up to that car and press the button on the app of your phone, the car would unlock, you get in the car, you drive it off wherever you want to go, and drop it off, and then someone else picks it up in that new location. It's a classic IoT application, but what I think is really interesting is it's one of these first examples of mobility as a service, and then changing the way that we move around cities and move around the suburban world. And I think that will actually have quite a big impact on society. So that's my favorite. It's quite an old one, but one I think is a real positive example.
That's great. And actually, the three of the answers too involve mobility. Yeah. So definitely something interesting. So actually, as for me, when I have a self-driving car, I'm moving to Canmore, which is like town, 15 minutes from here. So on my commute, I have a Zoom meeting with my students, daily stand-up, those type of things. Yeah, I'm gonna do that because I cannot buy a property in Banff. Yeah. Okay. Next question. So again, AI. So what's the AI application impressed you the most? What you find most interesting or most controversial? Something interesting.
Okay, so I'm lucky to be in the Google office in London, which we share with DeepMind. DeepMind, as you know, have been doing a lot of work in deep learning, AI, famously did AlphaGo and developed the kind of game playing apps and algorithm. Another thing that they've done is kind of less well known is a piece of research called StreetLearn. And what they've done is they've programmed an algorithm, an AI neural network with lots and lots of street view images, relatively small street view images of a number of cities around the world, New York, London, and Paris. And they basically use 3 neural networks to train the AI to navigate in the same way that we navigate. So one of the neural networks does image recognition, so it recognizes landmarks. Then there are 2 long-term, short-term memory networks that one manages the policy of the network, so to score strongly if you're going straight ahead as opposed to turning left and right. And another one's actually the model of the city. And what they've been able to do is to, in effect, train an AI to navigate in the same way that we navigate. And they can then give that AI in images for a new city, and it will work out how to navigate in that new city without any knowledge of the city itself. In the same way that if we were dropped into a city, we'd eventually work out how to navigate. And I think that's really interesting, because that's an example of an AI actually doing something that we as humans do, learning to navigate a city, a real geographical problem. If you're interested, I can give you the link to the academic report about it. But that's my favorite by a long way.
Yeah, that's a good one. Ingo?
I don't even really have a favorite, but what I stumbled upon lately was that the university where I'm teaching, where we all know those fish ladders, which are built next to in the rivers to allow the fish to climb. And these things cost usually between 5 and 10 million euros each. And they have been built without ever knowing if a fish can really climb and find them. And because the fish follows specific current patterns. And the situation was as follows. They figured out that the fish ladders, which in total costs millions of euros for a little river in Austria, no fish is ever using the ladder. And they try to calculate the currents in the river, but calculating currents following the mathematical approaches is damn hard. And so they used a type of popcorn and put it into the river, which was colored, and they fired up a drone and did a little video and just followed this popcorn, which was floating around on the river, and then used AI to detect the different current patterns. That was amazing because it was very straightforward. It was very simple. You could easily see where the currents are, or how the currents behave, and they behave more or less chaotic, right? That's the difficult thing. And yeah, they learned that they probably need to rebuild all the fish ladders because they had enormous place. A very simple approach. It was just not possible before to calculate where the current is, well, doing the right thing for the fish to find it. And now with AI, it was done in a week.
A feature about natural language processing, so we can just talk to the fish, maybe. But that I'll do. All right, please.
I'm thinking of maybe something different. But I've seen a lot of art created by artificial intelligence, which is very, very neat. We think that maybe systems computers will not be able to mimic any human behavior and creativity. Well, maybe they're crossing that level based on patterns or randomness, and maybe figure out how do they know that somebody finds something pretty or excitement, and find those patterns and creating art. I've seen, recently when I play guitar, sometimes I found places that they extract the music from YouTube, they figure out how to put the lyrics, and then automatically the notes appear. This is done automatically. There's some AI behind it. They're not sometimes perfect, and the chords that appear are weird, but they're very close to get these almost automatically created. Anyway, so that music and art, I see how this has been applied. I've heard also music created by systems, which is, interesting. Sometimes you will not feel the difference. So very incredible.
Yeah, maybe there's an AI, somebody can do a research about automatically generate the next best cartographical style, like a cartoon CSS, and it's more beautiful map.
And then this is related to spaces, right? Because depending on how people move in buildings, in malls, in other places, if you're able to also put music, art, different kind of context around you, you can change how people feel. So this is also, geo-related. Okay,
I'm gonna ask this last question. I'll let you go for beer. Yes. So the question is actually a big question, actually. So everybody there's no right or wrong answer. So the question is, what's the trend in geospatial that the biggest trend you think in geospatial, which is gonna happen in the next 5 years?
You got the microphone.
It's a tough question.
Next trend in the next 5 years?
Yeah, within the next 5 years.
Yeah, I think AI is one of those trends. I think the computer capacity have not yet reached the computing that we need to really do AI. We're getting a lot of data. We need a lot of more trained data, and that is happening. So I don't know what is going to happen in 5 years, but for sure it's going to be related to AI and how our lives change. Ingo says, yeah, home network is not going to not working. In 15 years, there's going to be smart cars everywhere. You're going to see drones flying more than ever. Your home will just be happening, working. The utilities will come and change everything you have because they're interested in making your home efficient, so they're able to generate business around it, based on AI as well. So I think all that automation and AI is going to be important in 5 years.
Thank you, Ingo.
Well, 5 years is not a long period of time, right? And I don't see any smart cars in 5 years driving around, or very few. I hope so, right? I love the automated infield traffic. I would give up my car immediately for one that just drives me where I want to go. What I see, there are trends that I hope will become more important, like natural language processing, where I can ask questions and the system gives me an answer based on all those geospatial data that is available, without me necessarily seeing any of these data sets, because I don't care about the data itself. But one trend that I actually see for the next 5 years is microsats. And I see less drones, in fact, and more microsats, because microsats become cheaper and cheaper. They are available 24/7. They have very good resolution, not if it's cloudy like that, and you have a visual sensor, but with other sensors they do. And just at the latest ISPRS conference or IGARS conference, they showed the calibration validation results for the microsats, and they are all on pair with the bigger counterparts. So I see this is certainly a development trend that will more materialize for the next couple of years.
Thank you.
Yeah, I agree. I think both of those are sort of trends that are, I suppose, a little bit beyond the industry, and it's often been the case with geospatial. We kind of ride on the coattails of the broader IT industry, so that's certainly the case in AI. And I think I agree with Inga. The big change for us specifically in geospatial, I think, is going to be around sensors, be they remote sensing sensors or in situ sensors or the sensors that we carry around in our pockets. And I think the creation of that sort of real-time data and its analysis is going to have many opportunities for this industry, where we slowly start to make that shift that we really need to do, which is moving geospatial from being something that's mostly dealt with static historic data to something that deals with real-time actionable information that is happening on a second-by-second basis. And I think that's a change that's long been coming, and I think with AI, with these sensors, I think it will finally come.
Thank you very much. So, do you have any questions you want to ask these gentlemen before beer? I know, it just can't kill all the questions, right? So
that's really a rhetorical question.
But thank you very much, gentlemen, and then thank you all. It's I think it's a wonderful day. It's very informative, and thanks to all the speakers. And then it's cover all kinds of topics are relevant to us. And then, yeah, maybe next year we'll organize another one. So thank you very much.